Reclaimed water or recycled water is former wastewater that is treated to remove solids and impurities, and used in sustainable landscaping irrigation, to recharge groundwater aquifers, to meet commercial and industrial water needs, and for drinking. The purpose of these processes is sustainability and water conservation, rather than discharging the treated water to surface waters such as rivers and oceans. In some cases, recycled water can be used for streamflow augmentation to benefit ecosystems and improve aesthetics. One example of this is along Calera Creek in the City of Pacifica, CA. The definition of reclaimed water, as defined by Levine and Asano, is the end product of wastewater reclamation that meets water quality requirements for biodegradable materials, suspended matter and pathogens. Simply stated, reclaimed water is water that is used more than one time before it passes back into the natural water cycle. Scientifically proven advances in water technology allow communities to reuse water for many different purposes, including industrial, irrigation and drinking. The water is treated differently depending upon the source and use of the water and how it gets delivered. Cycled repeatedly through the planetary hydrosphere, all water on Earth is recycled water, but the terms recycled water, or reclaimed water typically mean wastewater sent from a home or business through a pipeline system to a treatment facility, where it is treated to a level consistent with its intended use. The water is then routed directly to a recycled water system for uses such as irrigation or industrial cooling. There are examples of communities that have safely used recycled water for many years. Los Angeles County's sanitation districts have provided treated wastewater for landscape irrigation in parks and golf courses since 1929. The first reclaimed water facility in California was built at San Francisco's Golden Gate Park in 1932. The Irvine Ranch Water District was the first water district in California to receive an unrestricted use permit from the state for its recycled water. Such a permit means that water can be used for any purpose except drinking. IRWD maintains one of the largest recycled water systems in the nation with more than 400 miles serving more than 4,500 metered connections. The Irvine Ranch Water District and Orange County Water District in Southern California are established leaders in recycled water. Further, the Orange County Water District, located in Orange County, and in other locations throughout the world such as Singapore, water is given more advanced treatments and is used indirectly for drinking. In spite of quite simple methods that incorporate the principles of water-sensitive urban design for easy recovery of stormwater runoff, there remains a common perception that reclaimed water must involve sophisticated and technically complex treatment systems, attempting to recover the most complex and degraded types of sewage. As this effort is supposedly driven by sustainability factors, this type of implementation should inherently be associated with point source solutions, where it is most economical to achieve the expected outcomes. Harvesting of stormwater or rainwater can be an extremely simple to comparatively complex, as well as energy and chemical intensive, recovery of more contaminated sewage. History: storm and sanitary sewers were necessarily developed along with the growth of cities. By the 1840s the luxury of indoor plumbing, which mixes human waste with water and flushes it away, eliminated the need for cesspools. Odor was considered the big problem in waste disposal, and to address it, sewage could be drained to a lagoon, or settled, and the solids removed, to be disposed of separately. This process is now called primary treatment, and the settled solids are called sludge. At the end of the 19th century, since primary treatment still left odor problems, it was discovered that bad odors could be prevented by introducing oxygen into the decomposing sewage. This was the beginning of the biological aerobic and anaerobic treatments which are fundamental to wastewater processes. By the 1920s, it became necessary to further control the pollution caused by the large quantities of human and industrial liquid wastes which were being piped into rivers and oceans, and modern treatment plants were being built in the U.S. and other industrialized nations by the 1930s. Designed to make water safe for fishing and recreation, the Clean Water Act of 1972 mandated elimination of the discharge of untreated waste from municipal and industrial sources, and the U.S. federal government provided billions of dollars in grants for building sewage treatment plants around the country. Modern treatment plants, usually using oxidation and/or chlorination in addition to primary and secondary treatment, were required to meet certain standards. Current treatment improves the quality of separated wastewater as solids or sludge. The separated water is given further treatment considered adequate for non-potable use by local agencies, and discharged into bodies of water, or reused as reclaimed water. In places like Florida, where it is necessary to avoid nutrient overload of sensitive receiving water, reuse of treated or reclaimed water can be more economically feasible than meeting the higher standards for surface water disposal mandated by the Clean Water Act. Terminology: there is no one-size-fits-all solution to water reuse, but there are many safe and scientifically proven options that allow communities to sustain their local water supplies. Below are terms scientists and water experts use to describe some of these reclaimed water options. Reused water is water used more than once or recycled. Potable water is drinking water. Potable reuse refers to reused water you can drink. Non-potable reuse refers to reused water that is not used for drinking, but is safe to use for irrigation or industrial purposes. De facto, unacknowledged or unplanned potable reuse occurs when water intakes draw raw water supplies downstream from discharges of treated effluent from wastewater treatment plants, water reclamation facilities or resource recovery facilities. For example, if you are downstream of a community, that community unregistered trademark S used water gets put back into river or stream and is delivered downstream to your community and becomes part of your drinking water supply. Planned potable reuse is publicly acknowledged as an intentional project to recycle water for drinking water. It can be either direct or indirect. It commonly involves a more formal public process and public consultation program than is observed with de facto or unacknowledged reuse. How potable reused water is delivered determines if it is called indirect potable reuse or direct potable reuse. Indirect potable reuse means the water is delivered to you indirectly. After it is purified, the reused water blends with other supplies and/or sits a while in some sort of storage, man-made or natural, before it gets delivered to a pipeline that leads to a water treatment plant or distribution system. That storage could be a groundwater basin or a surface water reservoir. Direct potable reuse means the reused water is put directly into pipelines that go to a water treatment plant or distribution system. Direct potable reuse may occur with or without a OE-engineered storage such as underground or above-ground tanks. Maximum water recovery. To determine maximum water recovery, there are various techniques that have been developed by researchers. For maximum water reuse, recovery strategies such as water pinch analysis. The techniques help a user to target the minimum freshwater consumption and wastewater target. It also helps in designing the network that achieves the target. This provides a benchmark to be used by users in improving their water systems. Benefits: the cost of reclaimed water exceeds that of potable water in many regions of the world, where a fresh water supply is plentiful. However, reclaimed water is usually sold to citizens at a cheaper rate to encourage its use. As fresh water supplies become limited from distribution costs, increased population demands, or climate change reducing sources, the cost ratios will evolve also. Using reclaimed water for non-potable uses saves potable water for drinking, since less potable water will be used for non-potable uses. It sometimes contains higher levels of nutrients such as nitrogen, phosphorus and oxygen, which may somewhat help fertilize garden and agricultural plants when used for irrigation. The usage of water reclamation decreases the pollution sent to sensitive environments. It can also enhance wetlands, which benefits the wildlife depending on that ecosystem. It also helps to stop the chances of drought as recycling of water reduces the use of fresh water supply from underground sources. For instance, the San Jose Santa Clara Water Pollution Control Plant instituted a water recycling program to protect the San Francisco Bay Area's natural saltwater marshes. Concerns: reclaimed water is highly engineered for safety and reliability so that the quality of reclaimed water is more predictable than many existing surface and groundwater sources. Reclaimed water is considered safe when appropriately used. reclaimed water planned for use in recharging aquifers or augmenting surface water receives adequate and reliable treatment before mixing with naturally occurring water and undergoing natural restoration processes. Some of this water eventually becomes part of drinking water supplies. A water quality study published in 2009 compared the water quality differences of reclaimed recycled water, surface water, and groundwater. Results indicate that reclaimed water, surface water, and groundwater are more similar than dissimilar with regard to constituents. The researchers tested for 244 representative constituents typically found in water. When detected, most constituents were in the parts per billion and parts per trillion range. DEET and caffeine were found in all water types and virtually in all samples. Triclosan was found in all water types, but detected in higher levels in reclaimed water than in surface or groundwater. Very few hormone steroids were detected in samples, and when detected were at very low levels. Holoacetic acids were found in all types of samples, even groundwater. The largest difference between reclaimed water and the other waters appears to be that reclaimed water has been disinfected and thus has disinfection byproducts. A 2005 study titled Irrigation of Parks, Playgrounds, and Schoolyards with Reclaimed Water found that there had been no incidences of illness or disease from either microbial pathogens or chemicals, and the risks of using reclaimed water for irrigation are not measurably different from irrigation using potable water. Studies by the National Academies of Science, the Monterey Regional Water Pollution Control Agency, and others have found reclaimed water to be safe for agricultural use. There is debate about possible health and environmental effects. To address these concerns, a risk assessment study of potential health risks of recycled water and comparisons to conventional pharmaceuticals and personal care product exposures was conducted by the Weight Reuse Research Foundation. For each of 4 scenarios in which people come into contact with recycled water used for irrigation, children on the playground, golfers, and landscape, and agricultural workers, the findings from the study indicate that it could take anywhere from a few years to millions of years of exposure to non-potable recycled water to reach the same exposure to PPCPs that we get in a single day through routine activities. Testing standards. Reclaimed water is not regulated by the Environmental Protection Agency, but the EPA has developed water reuse guidelines that were most recently updated in 2012. The EPA Guidelines for Water Reuse represents the international standard for best practices in water reuse. The document was developed under a cooperative research and development agreement between the U.S. Environmental Protection Agency, the U.S. Agency for International Development, and the global consultancy CDM Smith. The guidelines provide a framework for states to develop regulations that incorporate the best practices and address local requirements. Ongoing wastewater research sometimes raises concerns about pathogens in the water. Many pathogens cannot be detected by currently used tests. Recent literature also questions the validity of testing for indicator organisms instead of pathogens. Nor do present standards consider interactions of heavy metals and pharmaceuticals which may foster the development of drug-resistant pathogens in waters derived from sewage. To address these concerns about the source water, reclaimed water providers use multi-barrier treatment processes and constant monitoring to ensure that reclaimed water is safe and treated properly for the intended end use. Distribution and demand. Non-potable reclaimed water is often distributed with a dual piping network that keeps reclaimed water pipes completely separate from potable water pipes. In the United States and some other countries, non-potable reclaimed water is distributed in lavender pipes to distinguish it from potable water. The use of the color purple for pipes carrying recycled water was pioneered by the Irvine Ranch Water District in Irvine, California. In many cities using reclaimed water, it is now in such demand that consumers are only allowed to use it on assigned days. Some cities that previously offered unlimited reclaimed water at a flat rate are now beginning to charge citizens by the amount they use. Potable uses. Some water agencies reuse highly treated effluent from municipal wastewater or resource recovery plants as a reliable, drought-proof source of drinking water. By using advanced purification processes, they produce water that meets all applicable drinking water standards. System reliability and frequent monitoring and testing are imperative to them meeting stringent controls. The water needs of a community, water sources, public health regulations, costs, and the types of water infrastructure in place, such as distribution systems, man-made reservoirs, or natural groundwater basins, determine if and how reclaimed water can be part of the drinking water supply. Communities in El Paso, Texas and Orange County, California, for example, reuse water to replenish groundwater basins. Others, such as the Upper Occoquan Service Authority in Virginia, put it into surface water reservoirs. In these instances the reclaimed water is blended with other water supplies and/or sits in storage for a certain amount of time before it is drawn out and gets treated again at a water treatment or distribution system. In some Texas communities, the reused water is put directly into pipelines that go to a water treatment plant or distribution system. And in Singapore the reused water is bottled directly from an advanced water purification facility for educational and celebratory purposes. Though most of the reused water is used for high-tech industry in Singapore, a small amount is returned to reservoirs for drinking water. A 2012 study conducted by the National Research Council found that the risk of exposure to certain microbial and chemical contaminants from drinking reclaimed water does not appear to be any higher than the risk experienced in at least some current drinking water treatment systems, and may be orders of magnitude lower. This report recommends adjustments to the federal regulatory framework that could enhance public health protection for both planned and unplanned reuse and increase public confidence in water reuse. Modern technologies such as reverse osmosis and ultraviolet disinfection are commonly used when reclaimed water will be mixed with the drinking water supply. An experiment by the University of New South Wales reportedly showed a reverse osmosis system removed ethinyl estradiol and paracetamol from the wastewater, even at 1,000 times the expected concentration. Aboard the International Space Station, astronauts have been able to drink recycled urine due to the introduction of the ECLSS system. The system cost $250 million and has been working since May 2009. The system recycles wastewater and urine back into potable water used for drinking, food preparation, and oxygen generation. This cuts back on the need for resupplying the space station so often. Indirect potable reuse. Some municipalities are using and others are investigating indirect potable reuse of reclaimed water. For example, reclaimed water may be pumped into or percolated down to groundwater aquifers, pumped out, treated again, and finally used as drinking water. This technique may also be referred to as groundwater recharging. This includes slow processes of further multiple purification steps via the layers of earth, sand and microflora in the soil. Direct potable reuse. In a direct potable reuse scheme, water is put directly into pipelines that go to a water treatment plant or distribution system. Direct potable reuse may occur with or without a OE-engineered storage such as underground or above-ground tanks. Communities in Texas have implemented DPR projects, and the state of California is studying the feasibility of developing DPR regulations. Unplanned potable reuse. Water reuse occurs in various ways throughout the world. It happens daily on rivers and other water bodies everywhere. If you live in a community downstream of another, chances are you are reusing its water, and likewise communities downstream of you are most likely reusing your water. Unplanned indirect potable use has existed even before the introduction of reclaimed water. Many cities already use water from rivers that contain effluent discharged from upstream sewage treatment plants. There are many large towns on the River Thames upstream of London that discharge their treated sewage into the river, which is used to supply London with water downstream. This phenomenon is also observed in the United States, where the Mississippi River serves as both the destination of sewage treatment plant effluent and the source of potable water. Research conducted in the 1960s by the London Metropolitan Water Board demonstrated that the maximum extent of recycling water is about 11 times before the taste of water induces nausea in sensitive individuals. This is caused by the buildup of inorganic ions such as Cl, SO42, K+ and Na+, which are not removed by conventional sewage treatment. Space travel. Wastewater reclamation can be especially important in relation to human spaceflight. In 1998, NASA announced it had built a human waste reclamation bioreactor designed for use in the International Space Station and a manned-Mars mission. Human urine and feces are input into one end of the reactor and pure oxygen, pure water, and compost are output from the other end. The soil could be used for growing vegetables, and the bioreactor also produces electricity. Treatment improvements. As world populations require both more clean water and better ways to dispose of wastewater, the demand for water reclamation will increase. Future success in water reuse will depend on whether this can be done without adverse effects on human health and the environment. In the United States, reclaimed wastewater is generally treated to secondary level when used for irrigation, but there are questions about the adequacy of that treatment. Some leading scientists in the Maine Water Society, AWWA, have long believed that secondary treatment is insufficient to protect people against pathogens, and recommend adding at least membrane filtration, reverse osmosis, ozonation, or other advanced treatments for irrigation water. Recent advances in reverse osmosis have been in different countries, but have consistently produced very high-quality water all the same. In Singapore, reclaimed water, also known as Newater, has become cleaner than the government-issued tap water. Also, according to Bartels, the BDOC demonstration plant, which uses aeromembranes, has successfully run for the past 3 years, producing high-quality wastewater all the while. Seepage of nitrogen and phosphorus into ground and surface water is also becoming a serious problem, and will probably lead to at least tertiary treatment of reclaimed water to remove nutrients in the future. Even using secondary treatment, water quality can be improved. Water quality can also be improved as it passes through the subsurface mixing zone where surface water and groundwater combine. Testing for pathogens using polymerase chain reaction instead of older culturing techniques, and changing the discredited fecal coliform indicator organism standard would be improvements. In a large study, treatment plants showed that they could significantly reduce the numbers of parasites in effluent, just by making adjustments to the currently used process. But, even using the best of current technology, risk of spreading drug resistance in the environment through wastewater effluent would remain. Some scientists have suggested that there need to be basic changes in treatment, such as using bacteria to degrade waste based on nitrogen and not just carbonaceous waste, saying that this would greatly improve effectiveness of treatment. Currently designed plants do not deal well with contaminants in solution. Dewatering solids is a major problem. Some wastes could be disposed of without mixing them with water to begin with. In an interesting innovation, solids could be removed before entering digesters and burned into a gas that could be used to run engines. Emerging disinfection technologies include ultrasound, pulse arc electrohydraulic discharge, and bank filtration. Another issue is concern about weakened mandates for pre-treatment of industrial wastes before they are made part of the municipal waste stream. Some also believe that hospitals should treat their own wastes. The safety of drinking reclaimed water, which has been given advanced treatment and blended with other waters, remains controversial. Other alternatives, in urban areas where climate change has threatened long-term water security and reduced rainfall over catchment areas, using reclaimed water for indirect potable use may be superior to other water supply augmentation methods. One other commonly used option is seawater desalination. Recycling wastewater and desalinating seawater may have many of the same disadvantages, including high costs of water treatment, infrastructure construction, transportation, and waste disposal problems. Although the best option varies from region to region, desalination is often superior economically, as reclaimed water usually requires a dual piping network, often with additional storage tanks, when used for non-potable use. A less elaborate alternative to reclaimed water is a greywater system. Greywater is wastewater that has been used in sinks, baths, showers, or washing machines, but does not contain sewage and has not been treated at the same levels as recycled water. In a home system, treated or untreated greywater may be used to flush toilets or for irrigation. Some systems now exist which directly use greywater from a sink to flush a toilet. Perhaps the simplest option is a rainwater harvesting system. Although there are concerns about the quality of rainwater in urban areas, due to air pollution and acid rain, many systems exist now to use untreated rainwater for non-potable uses or treated rainwater for direct potable use. Urban design systems which incorporate rainwater harvesting and reduce runoff are known as water-sensitive urban design in Australia, low-impact development in the United States and sustainable urban drainage systems in the United Kingdom. There are also concerns about rainwater harvesting systems reducing the amount of runoff entering natural bodies of water. Worldwide applications and acceptance. As of 2010, Israel leads the world in the proportion of water it recycles. Israel treats 80% of its sewage, and 100% of the sewage from the Tel Aviv metropolitan area is treated and reused as irrigation water for agriculture and public works. The remaining sludge is currently pumped into the Mediterranean, however a new bill has passed stating a conversion to treating the sludge to be used as manure. Only 20% of the treated water is lost. The recycled water allows farmers to plan ahead and not be limited by water shortages. There are many levels of treatment, and many different ways of treating the water, which leads to a big difference in the quality of the end product. The best quality of reclaimed sewage water comes from adding a gravitational filtering step, after the chemical and biological cleansing. This method uses small ponds in which the water seeps through the sand into the aquifer in about 400 days, then is pumped out as clear purified water. This is nearly the same process used in the space station water recycling system, which turns urine and feces into purified drinking water, oxygen and manure. To add to the efficiency of the Israeli system, the reclaimed sewage water may be mixed with reclaimed seawater, along with aquifer water and fresh sweet lake water, monitored by computer to account for the nationwide needs and input. This action reduced the outdated risk of salt and mineral percentages in the water. Plans to implement this overall usage of reclaimed water for drinking are discouraged by the psychological preconception of the public for the quality of reclaimed water, and the fear of its origin. As of today, all the reclaimed sewage water in Israel is used for agricultural and land improvement purposes. The second largest waste reclamation program in the world is in Spain, where 12% of the nation's waste is treated. The leaders in use of reclaimed water in the U.S. are Florida and California, with Irvine Ranch Water District as one of the leading developers. They were the first district to approve the use of reclaimed water for in-building piping and use in flushing toilets. In a January 2012 U.S. National Research Council report, a committee of independent experts found that expanding the reuse of municipal wastewater for irrigation, industrial uses, and drinking water augmentation could significantly increase the United States' unregistered trademark total available water resources. The committee noted that a portfolio of treatment options is available to mitigate water quality issues in reclaimed water. The report also includes a risk analysis that suggests the risk of exposure to certain microbial and chemical contaminants from drinking reclaimed water is not any higher than the risk from drinking water from current water treatment systems, and in some cases, may be orders of magnitude lower. The report concludes that adjustments to the federal regulatory framework could enhance public health protection and increase public confidence in water reuse. As Australia continues to battle the 7-10-year drought, nationwide, reclaimed effluent is becoming a popular option. Two major capital cities in Australia, Adelaide and Brisbane, have already committed to adding reclaimed effluent to their dwindling dams. Brisbane has been seen as a leader in this trend, and other cities and towns will review the Western Corridor recycled water project once completed. Goulburn, Canberra, Newcastle, and regional Victoria, Australia are already considering building a reclaimed effluent process. According to an EU-funded study, Europe and the Mediterranean countries are lagging behind California, Japan, and Australia in the extent to which reuse is being taken up. According to the study, the concept is difficult for the regulators and wider public to understand and accept. Applications: Indirect potable reuse, Orange County, California, London, United Kingdom. Singapore, Payson, Arizona, the Torreal project in the Vierne coastal region of Belgium, which began operating in 2002, Virginia Ochilcan Reservoir, the Upper Ochilcan Sewage Authority plant discharges its highly treated output to supply roughly 20% of the inflow into the Ochilcan Reservoir, which provides drinking water used by the Fairfax County Water Authority, one of the three major water providers in the Washington, D.C. metropolitan area. Non-potable reuse, Austin, Texas, Caboolture and Maruachi LGAs currently provide reclaimed water for industrial use. Users must apply for a key to be able to access the compounds in which the outlets are located. Clark County, Nevada, Clearwater, Florida, Contra Costa County, California, Melbourne, Australia, Mount Buller Ski Resort uses recycled water for snowmaking. San Antonio operates the largest recycled water system in the United States. Sydney, Australia, Tucson, Arizona, San Diego, California, St. Petersburg, Florida, proposed. In some places, reclaimed water has been proposed for either potable or non-potable use. Southeast Queensland, Australia, Newcastle, New South Wales, Australia. Canberra, Australian Capital Territory, Australia, Los Angeles, California. By 2019, the Los Angeles Department of Water and Power will build a plant to replenish their groundwater aquifer with purified water in order to deal with a shortage of rain and snowfall, restricted water imports and local groundwater contamination. Enterprises, Brack Systems, Canada, Ekplay, Netherlands, see also. References. External links. Waterwise, a non-profit non-governmental organization dedicated to promoting the wise use of water. Wait Reuse, a non-profit organization whose mission is to advance the beneficial and efficient use of water resources using reclamation, recycling, reuse, and desalination. Watchers Protecting the Environment, a non-profit organization dedicated to finding the truth about reclaimed sewage water and sludge. Help for Sewage Victims, a non-profit organization dedicated to factual research for the protection of sewage victims.